A package has arrived. Let's see what's inside. First up, we have a Z-Moon 12-inch LED light bar for UTVs, trucks, boats, and is 12 to 24 volts. Made in, of course, China. So I bought this from Amazon for a future project. I want to hopefully install this on my snowblower to light up the night, because the little incandescent light that's on it now, it's adequate, but I'd like to have something a little better. So here's a look at it. It's got loads of LEDs in it, and it's got a nice aluminum case. Got some hardware to mount it. You're basically L brackets, a couple of Allen head bolts, 2-wire cord, and hopefully, and I have to measure it to make sure it doesn't go over 5 amps, because that's all a typical single light snowblower light alternator is capable of putting out, is 5 amps. I'm not looking to use the whole 5 amps because that would have a very short lifespan of the 5 amp alternator. So I'm looking around about between 2.5 amps and 3 amps. I believe the light that it's on now is a 28 watt incandescent light. So I think that's around a little over 2 amps or something like that. And unfortunately, there's not a lot of specifications on how many amps this thing draws. It's got, you know, the wattage and stuff like that, but I'm going to test it out to make sure it doesn't go over the 5 amp capability of the alternator. So I got a couple other things that came in that package. It's a packet of capacitors, and these are 50 volt 2200 microfarads, and some full wave bridge rectifiers, because this is not going to be just plug and play, because the alternator puts out alternating current. This needs DC current. So this rectifier is going to take AC voltage and bring them down to DC voltage. So here's the part number of this bridge rectifier. So I watched a couple of videos on people who did the same project, and they wire up their bridge rectifiers, and they don't really tell you how to hook these up without a lot of minutes upon minutes of just plain psychobabble. When you look at one of these things, you see that it's got a positive sign and an AC side. So the AC side, this one terminal is AC. That doesn't mean that this is AC. The way this works is everything is diagonal. So this is AC, this is AC. And it doesn't matter which side you hook up your wires to, because it's alternating current, so it doesn't matter. Now on your DC side, you can see the positive here. This is your positive output, and this is your negative side output. So when I hook this up, it's going to be AC to AC, and then positive to negative. Now, the reason I got the capacitors is I'm going to use two of these in parallel, and I'm going to hook them up to the positive side and the negative side. And what that's going to do is when this thing rectifies from AC to DC, the DC side is going to have a little bit of a wave. So what that'll do is it'll cause this light to flicker a little bit because the current and the voltage is going up and down. So right now I want to test how much current this thing draws. So I'm going to take a little pause here, and for you I'll be right back in a split second. Okay, I have my DVOM hooked up in series with the light. I have my positive lead going into the meter. It is coming back out of the meter and going into the positive side of the light, and the ground is going back to the power supply. Right now I have my camera autofocus and exposure set to manual so the camera will not compensate, and I will flip the switch and we'll see how many amps this light draws. And it looks like it's just a hair over 3 amps, which is perfect. That will not overdrive the 5 amp alternator on the snowblower. So that should be an excellent upgrade. So in my next video, I will wire up the light to the rectifiers and tie in the capacitors, and then maybe I'll actually show you in the end what it looks like if it ever snows again in the dark. We'll see you next time. Take care, and see you in the next video. Bye-bye.